Alright everyone, last problem. So we want to show that for all the natural numbers n and n, that 18 plus 36 plus 54 plus ... plus 18n is equal to 9 times n plus 1. And so notice that nothing is written here, it's up to us to fill it all in. And so for the condition 1, we want to write show n equals 1 is true. Well, then that would mean 18 should equal 9 times 1 times 1 plus 1, which is 18, and so we showed the first condition. The second condition is to suppose the statement holds for n equals k. That is, we have 18 plus 36 plus 54 plus ... plus 18k is equal to 9k times k plus 1. And we want to show the k plus 1th term is true. We want to show that the statement holds for n equals k plus 1. So we want to show, so the k plus 1th term well, I don't want to write that. So what I mean is, we just literally want to show the statement holds true for n equals k plus 1. So 18 plus 36 plus 54 plus ... plus 18k plus 18k plus 1 is going to equal 9 times k plus 1 times k plus 1 plus 1. Okay, so we want to show that this left side is the same as this right side. And to do that, we want to use what we have to be true, what we are assuming to be true. And what we're assuming to be true is that the 18 plus 36 plus 54 plus ... plus 18k is 9k times k plus 1. That this kth statement is true. And when we look at this left side, the kth statement is right here. And so what that means is that this sums to 9k times k plus 1. And then this is going to be plus 18 times k plus 1. So we have the induction hypothesis where we see the statement that we're assuming to be true. So we know that it's equal to 9k times k plus 1. Bring down that k plus 1, that next k plus 1th term, and then it's supposed to equal 9 times k plus 1 times k plus 2. Well, if we look carefully at this, we can see that there's a factor of k plus 1 in common. So I can factor out a k plus 1. And be left with 9k plus 18. And then I can take out a 9 in that second factor. So 9 times k plus 1 times k plus 2. And I just got a little lazy here. I stopped writing this. And then now we've officially showed that these are the same thing on the left and right. And so, if we can conclude, since conditions 1 and 2 hold, or are satisfied, the statement is true for all n in the natural numbers by principle of mathematical induction. Square box, or if you want, you can be writing QED. Ugh, this stupid pen. QED. Alright, so with these induction problems, please follow like the recipe. Do your conditions 1, conditions 2. You're always trying to show that that left side is the right side for that k plus 1 term, so don't mix and match them, and always state your conclusion. Alright, have fun with 11.4.